Hi everyone. In this series of video, I am going to explain the question and answer of chemistry from last 10 years JEE Mains and JEE Advanced examination. I have divided the whole things into organic chemistry, inorganic chemistry and physical chemistry. Initially, I will focus on organic chemistry. In this first video of the series, I will discuss about the question and answer of organic chemistry that came in the JEE Main examination 2010. Although there are many videos available in YouTube for the same topic, but what I found in many cases that either the answers are incorrect. If they are correct, then they are not explained. If they are explained, then they are explained in an illogical way. So the first problem is this one, where it has been asked that the synthesis of 3-octane is achieved by adding a bromoalkane into a mixture of sodium amide and an alkyne. The bromoalkane and alkyne respectively are, here are the options. So to answer this kind of problem, first you have to think about the number of carbon atom. As it has been asked that it will be a 3-octane. Octanes mean there should be 8 carbon. Now if we check option number 1, we can see if we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 carbons in this option number 1, so automatically cancelled. Next we have to think about the reaction mechanism or how the molecule is synthesized. So if we check, here is it. Here is the alkyne. R could be anything depending on the chain length of the alkyne. So this is the general mechanism. Here we are using the base sodium amide, which is actually going to deprotonate this proton. This proton is very acidic. It is attached with the sp hybridized carbon, so it is very acidic. So now a nucleophile is formed due to the deprotonation, and this nucleophile is going to attack an alkyl halide. Here also I have written R-Br because it depends on the chain length. Now this is the general synthetic procedure or the general mechanism of the whole process, and there will be a SN2 kind of attack where the nucleophilic attack will happen to the alkyl bromide and you will get the product. Now we have to think about the structure of the alkyne. As we can see that it has been asked to form 3-octane or to synthesize 3-octane. That means the structure of the 3-octane will be like this, where this is number 3 carbon which is having that triple bond. Very simple compound. Now there could be 2 ways by which we can synthesize this compound. Either you have to take this one and this one as a starting material. If you check the reaction mechanism that I have given here, in this case R will be this and R-Br will be this. So R C triple bond CH will be this one and R-Br will be this one. In the next case, R-Br will be this one, so R- will be this CH2C CH3 CH2 part, and this part will be the RCH. So this one will be the R and R single bond C, or sorry, triple bond C and H. Anyway, so this is what it is. Now you don't have to think about so much, you just calculate or just match with the option. Here you can see that this option, is it there among these 3 left options? So if you check 1, 2, 3, 4, 1, 2, 3, 4, and here 1, 2, 3, 4 carbon. So 1, 2, 3, 4 carbon with a Br. So this one is the correct answer. So this is the way we have to think for answering this kind of problem. We have to draw, or we have to recall the mechanism, how it will happen. Then we have to draw the structure of the molecule. That is very important. We have to draw the structure of the molecule that needs to be synthesized. And if we draw the structure of the molecule, then we can very easily say that how the molecules can be synthesized. For this specific molecule, it can be synthesized in 2 ways, as I have written here, and one of the way is matching with our option. So we will select that option. In the next question, we can see that a structure is given here where there are two different kind of ring system connected with a specific kind of linkage. Now this kind of system are carbohydrates, and there are two different kind of rings here. It has been asked that which ring is of which kind and what are the linkage by which they are connected. Now to answer this kind of question, you need to know that what are the general names of this kind of rings. So whenever there is a 6-membered ring with the oxygen like this, it is called a pyran ring, or this kind of system is also known as pyranose. So the left hand side ring is a pyranose ring. That means ring A is pyranose because it look like, means it has a similar kind of structure. It doesn't have the double bond, of course. In pyranose there will be no double bond, but these rings look similar. That means 6-membered ring with an oxygen. Same way, if you check this furan system and this ring, that means ring B, you can see that they are also similar. They don't have the double bond, but they look similar. They have this 5-membered structure with an oxygen here. So this kind of ring is known as furanose. Now about the connections by which they are connected. I have drawn 4 different kind of structure here. You can see that they have specific names like alpha, beta, and why are they are such like alpha, beta, what this alpha, beta term denotes. Actually, you have to check the position of this anomeric OH group. What is anomeric OH group? Anomeric OH group is the hydroxide group connected to the alpha carbon of this oxygen. So this is the oxygen and this alpha carbon, that means carbon number 1, has a hydroxide group, whereas another alpha carbon, that is C5 here, doesn't have any hydroxide group, so we do not consider that one. So we have to check now the position of this hydroxide group with respect to this CH2OH, that means carbon number 6. So if this CH2OH and this hydroxide are in opposite side, then it will be an alpha pyranose structure. And if this CH2OH, that is ring, that is carbon number 6, and the anomeric hydroxide group are in the same side of the ring, then it is a beta pyranose structure. In case of furanose, again we have to check for the alpha hydroxide. We can see the alpha hydroxide or the hydroxide group connected with the alpha carbon is in our left hand side, and now we have to compare the position of the hydroxide group with relative to this CH2OH, that is again carbon number 6. So if they are in the same side, then it is a beta furanose structure. If they are in the opposite side, then it is an alpha furanose structure. Now let us come back to our problem again. Here we can see that the A ring, that is the pyranose ring, has the oxygen, this oxygen, that means which was hydroxide before, but after the linkage is formed, it is something else. It is now a ethereal linkage. Anyway, the position of this oxygen is just opposite to this CH2OH group. That means opposite plane. So it is of course a kind of alpha pyranose, or this linkage is an alpha glucoside linkage. So if you check option A, you can see that ring A, that means this ring, is pyranose with a alpha glycosidic linkage. So this one is the correct answer. So ring A is not furanose, so B is not right. Ring B is furanose, fine. And now check if it is a glycosidic linkage. Ring B, if we check ring B, it is a beta glycosidic linkage because this O and this CH2OH are in the same side. So this is a beta glycosidic linkage. So ring C, although ring means the option C, where ring B is furanose, is correct, but the other part, that is, it is not an alpha glycosidic linkage, so it is wrong. Ring B is pyranose, that means this is not pyranose, so option D is also incorrect. So for this question, option A will be the correct option, because in this option it has been said that ring A is pyranose with an alpha glycosidic linkage. And what is alpha glycosidic linkage? Where the anomeric oxygen is opposite to the C6CH2OH group. In our next problem, a very simple situation has been given where there is an ether and a halogen acid. We have to answer, or we have to say that which will be the product upon this reaction. So you have to remember a very important thing here, that whenever an ether reacts with an halogen acid, there will be a breaking of the ether linkage. That means the ether linking will break, and a halide along with an alcohol will form. Depending on the structure of the starting material, the alcohol will form and the halide will be decided. Now look at this specific compound, the starting material, where we have a phenyl system at one hand and a methyl system, that is alkyl system in another hand. So what will happen? The oxygen, which has the lone pair, will accept the proton from the H pair. Very simple. This oxygen only has the lone pair, so it will take the proton. There is no other option. So it will have the positive charge now. Yep. And now the bromide, that is the Br minus, has two options. Either it will attack the CH3 to form the phenol and methyl bromide as the product if it goes via this green line. If it goes via this red line, then the bromide will attack the benzene ring, forming methanol and benzyl bromide. But the problem is, this bromine minus itself has a negative charge. That means bromide anion has a negative charge, and benzene nucleus also has an electron density, because it is a system with many delocalized pi electrons. As a result, bromine minus cannot attack this place because of the electrostatic repulsion between the minus charge of bromide and the delocalized pi electron of the benzene. So another option, that means the green line, so bromide will attack the CH3 and the ring will open, this bond will break, and it will get the product as phenol and CH3Br. So now let us check which option has these two products. So if you go A, B, C, D, so if we check D, we have the product. This is, here it is not very clear, so let me draw it. It is the phenol with the OH group here, and this is the CH3Br. So CH3Br. So we have our product here. Our next problem is related to bromination of phenol. Here we can see that in the question there is a phenol, the structure of a phenol here, and over the arrow we can see sodium hydroxide and bromine. Sodium hydroxide is a base, so whenever you put sodium hydroxide in phenol, it will take out the proton from the hydroxide group, because this proton is very acidic in nature. So sodium hydroxide as a base will take that proton. What we will have now? We will have a negative charge over the oxygen atom, and this negative charge will be stabilized due to the aromaticity of the benzene ring. So resonance stabilized negative charge. So now this negative charge will start to move, and first it will come to the ortho position here. Then again it will start moving and it will come to the para position. Now when it will be in para position, it may react with the bromine molecule. So when it will react with the bromine molecule, as we can see that bromine molecule is generally non-polar in nature, because it is two same kind of atom connected with a covalent bond. It will be non-polar, but a charge may be induced, like in this case the bromine molecule, when it will come near to this negative charge, so this end of the bromine will be induced with a positive charge and the opposite end will be induced with a negative charge. And now this positively partially charged bromine will be attacked by this negative charge, and intermediate like this will form. This intermediate will readily remove the H plus, and this one will form. Next, what will happen? The thing will not stop here. So O minus will again resonate, and the negative charge will again come to the ortho position. Now this negative charge in ortho position will again react with another bromine molecule the same way. That means first induction of a positive charge and then reaction. And again there will be a removal of H plus, and you will have this one as a product. Not as a product, but it is an intermediate because we still have the minus charge. So what may happen in the next step? It may take a proton from the system to form a substituted phenol. Now this much is enough because we need this two structure only, and these two structure are the intermediate which will be there during the whole procedure. These are the two intermediate. Now if you check the different structure given in the option, only A and C is matching with our prediction. That means C, which is this intermediate, and A is this intermediate. And after that what will happen? After that another more step may happen which is not there in our option, but that will be the product. That means, or it may go via this link. Let me draw it. So next step what will happen? Next step, the oxygen, the negatively charged oxygen here, will again resonate. That means O minus will shift, but now in this direction. So this one will come over here, and this one will come over here, and this one over here. So another ortho position will take the negative charge now. So something like this will form. So double bond O. Here we already have the beer, double bond, negative charge. Now this negative charge may again react with a Br2 to form something like this. So beer with O minus. Of course there will be a removal of H plus ion. Now then it may take a proton from the system, or it may remain as a sodium salt, doesn't matter, because we only need the intermediate, and only this two intermediate is matching with our option. So A and C will be the correct answer for this question. So in our next question, a system or a structure which is incomplete is drawn here, and it is said that it is the structure of 2,2-dimethylbutane, and we have to predict what is X and Y in this structure. So first in this case you have to draw the structure of 2,2-dimethylbutane. Here I have already drawn the structure. You can see here it is the butane, first the butane, that means 4 carbon in a line, and then in number 2 carbon there will be 2 methyl group attached. So this is the structure. Now depends how we are looking at the molecule. Suppose we are looking from this direction, that means the eye of number 1 observer, then how we will see the molecule, or how we will draw the molecule in a Newman projection. So if you see like this, then you have to draw it like this. So this is the farthest carbon, that means this carbon, number 2 carbon, and 1 is the closest carbon. So 1 is here, the center, and 2 is the big round over there. So this big round has 2 methyl group attached, CH3, CH3, and what are the other hand? One is this one, and the other hand is this ethyl group. So here will be an ethyl group, C2H5. Fine. And the closest carbon, that is number 1 carbon, has 3 hydrogens. So hydrogen, hydrogen, hydrogen over here. Now, if we look through this direction, that means observer 2. So this one is observer 1, and now the second one is observer 2. So if you look as observer 2, then methyl group. So this carbon, that means carbon number 3 is the carbon you are looking at. So methyl group here, this is the closest carbon. So this is the central one. So it has also 2 hydrogen. So this one and this one, and this is the farthest carbon. Farthest carbon is the one which is carbon number 2. So it also has 2 methyl groups. So here, carbon number 2 has another methyl group, CH3. So if you look through the system as observer 1, you can see it like that. So in this case, X will be H and Y will be C2H5. And if you look like observer 2, then X will be CH3 and Y will also be CH3. Now let us look at the options available. So option C, if you check, where C2H5 and H is given, is not of course the correct answer, because in this case C2H5 is X. We don't have C2H5 as X in any of the option. So this is not correct. In that option number A, we can see that both are H, which is also not correct. In any of the option, it is not correct. In option number B, X is H, so X is H, and Y is C2H5. Okay, Y is C2H5. So if you see the molecule as observer 1, then option B is correct. And in case of D, you can see that X is CH3 and Y is also CH3. That means this one, X is CH3, Y is CH3. So if you look at the molecule as observer 2, then D is the correct answer. So both B and D are actually the correct answers. Our next question is about solubility. Here is it asked that among these following compounds, which will be soluble in sodium hydroxide? That means sodium hydroxide, as we know, is a base. So in a compound where there is a very active proton available, which can be taken out by sodium hydroxide and a salt may form, those compounds will be soluble. Now let us check one by one. So compound number A is a N,N-dimethyl benzene, but the problem is in this case, so I will write compound A here. Here we don't have any active hydrogen, so it will not behave as an acid in presence of sodium hydroxide. So this will not form any salt and it will not soluble. So it will not be soluble. So I am putting a cross over here. Now here we have a carboxylic acid group in compound number B. So it will be soluble because this will form a salt like this, CO minus Na plus. This kind of salts are highly soluble because this proton can be taken out by the base. In our next sample, that is sample number C, we have a OH group here where there is a proton, but this proton is not enough acidic to be taken out by sodium hydroxide. So any alcoholic OH or any alcoholic proton cannot be taken by sodium hydroxide. Hence, there will be no salt formation. As a result, it will not be soluble. In case of phenol, phenol is very acidic. So this phenolic OH will be taken by sodium hydroxide. So the salt form will be something like this. O Na. So O minus Na plus, salt formed and highly soluble. So far 2 compounds will be soluble with sodium hydroxide or in sodium hydroxide solution. In case of compound number E, we can see that there is no active hydrogen present in the system, hence it will not form any salt and will not be soluble. In option number F, we have an active hydrogen here. This will be taken by sodium hydroxide and it will form a salt like this. And salts are very soluble, so this one will also be soluble. In option number G, here also we can't see any active hydrogen, so no salt formation, hence no solubility. In option number H, yes, we have the carboxylic acid group here again, so it will be, this proton will be taken by the sodium hydroxide, so you will get a salt like this. And this kind of salt, as I have already mentioned several times, that very soluble. So we have this 4 compound which will be soluble in sodium hydroxide solution. If you have liked my video, please click the thumbs up button as well as share the link with other people. And for more videos, please subscribe my channel and press the bell icon. Most importantly, please comment below about your needs related to chemistry so that I can make more videos on several other topics.